I hope you can all see my screen. Hello, everyone. So I'm Yann GIORGIUTTI. I'm sitting in the R&D department of RTE, the French TSO. My background is naval architecture, and I'm responsible of all the floating offshore substation aspect at RTE. So today, yes, I will show you and present you what the new challenges bring the development of the offshore wind development brings for a TSO from a TSO perspective in France, and how the floating offshore substation could help in responding to these new challenges. Today, so the content of my presentation is first to remind what are the RTE's mission as a TSO, as a French TSO and a public utility. I will present the offshore wind development in France and the challenges that it induces for the TSO, and the AFOSS-DC outcomes and remaining work from the French context perspective. So one word about the RTE's missions. Here I have summarized the key accountabilities and the most relevant for us at the R&D. So yes, RTE is the French transmission system operator. We are a public utility who works every second to guarantee long-term access for French people to decarbonize electricity through its network. We provide the same quality of service across the country until the borders. And we have also dedicated missions that are to plan, design, operate the electricity transmission system, and also to advise the French authorities on future electricity needs and required investments. And I think these two last bullet points are really what is driving the work that we are doing at the R&D concerning the floating offshore substation. Now I will present you the challenging from the TSO perspective that brings the offshore wind development in France. One word about the offshore wind development in France. I don't know if you are familiar with this, but in 2024, in October, the French authority divulgated a decree highlighting where the offshore wind will be developed in the next decades. There are similar characteristics for their zones. The area are of several hundred of square kilometers. The distance to the shore is increasing, above 150 kilometers. The water depth is also increasing. We have zones from 90 meters of water depths of up to 200 meters. And we have two main coasts to develop, namely Atlantic coasts and Mediterranean coasts. What does it mean in terms of offshore substation and how to connect the power generated to the grid? As you saw, all these zones to be developed are very wide, which means that we will have most probably very large wind farms to connect or several wind farms to connect to the grid. The distance to the shore also is increasing, and then it makes the transport of electricity very complex, and then the need to switch from the AC to the DC technology. The water depth also is increasing, and then it challenges the technical economical equation of bottom fixed, well-known offshore substation. And then there is a determination of a break-even point from for the offshore substation solutions to be found per site and considering all the project phases and aspects. As I mentioned, so we have when the depth increase, we have two concurrent solutions, or I would say preferably two solutions that are completing each other that we can choose. The main driver here is the water depth, but as I mentioned, also there is also the other aspects like overall site condition, OSS types. On the left-hand side, there is the bottom fix solution, which is well known with a very advanced TRL, technology readiness level, for which we have also already some engineering and projects in execution. And on the right-hand side, there is the floating solutions, for which, in terms of floating offshore substation, it requires de-risking, still de-risking. All these solutions bring advantages and disadvantages that I won't list today, but that you can read. And for making a choice, we need to study what type of OSS we want to build and connect, the site condition for sure, but also the construction and installation needs. The problematic then is to study the site condition. So as I mentioned, for us, we are the French TSO, so we are interested only by the French the French context and French site conditions. There is the SS type, so HVAC, or in our case for long-term offshore wind development, HVDC. And how to switch the common way to build an OSS and an OSS topside from challenges of a bottom fix platform to the floating offshore substation, how to rearrange the layout of such platform. There is also the need to study the different technologies that are available. So for the bottom fixed technologies, but also for the floating substructures. And finally, we need to study the execution means. And it is only by studying all of these that we are able to make a decision on how to choose the best solution in order to connect and to build an offshore substation. How to make a decision for ensuring a good quality of decision and making a choice. We are studying several aspects that must be considered for decision making. First of all, it concerns the feasibility. So we are studying the technical feasibilities, the industrial, political, and regulatory and normative one. We are also studying for sure the cost and penalties linked to a given solution. So on all the value chain, from the development phase up to the decommissioning phase. And we are also studying the risk profile, which is attached to each solution, and then the contingencies and the insurability that it involves. In the R&D department, we are really focused on the orange, bold orange aspects mentioned in this slide. Our focus is on the main technical challenges for a floating offshore substation that we have identified. It consists mainly to de-risk some technologies that has to support the motions and acceleration of a floating substructure. So mainly, we have identified the converter station that needs to be still de-risked. For sure, there is the DC dynamic cables with high voltages to be de-risked. And more generally, there is the HV electrical equipments, including transformers, but also DCGAs that we believe is a key aspect to de-risk in order to make sure that we are able to save some space on the topside, which is a very important factor for floating offshore substations. So our challenges, but also our objectives, is to be able to estimate the technical, economic, and environmental applicability of floating offshore substations, to be able to compare it to bottom-fixed offshore solutions, and then to put in place some future offshore connection strategy plan. And it is directly connected to the RTE's mission that I have presented at the beginning of my presentation. Then there is a second aspect, a technical aspect, which is key for us, is to be able to specify the different requirements that equipment must sustain for a floating offshore substation. And then the objective is to be able to adapt our specifications for floating offshore substation, and to issue then in the future for the coming offshore wind developments invitation to tender, and then evaluate the supplier bids. One important aspect is also to address the industrial challenge, check that the infrastructure and skills of European and industry and supply chain is compatible with the manufacture and the maintenance of this new type of connection, and then build our industrial strategies. And last but not least, our objective is also to assess the environmental impacts, propose also follow-up protocols, and then we must adapt our specification to the environmental aspects. That brings me to the last part of my presentation, where I will show you what are for RTE the AFOSS-DC outcomes, and what we have still as remaining works. Here on that slide, you have the different work stream in RTE's roadmap. So as I said, we want to be as holistic as we can, and then address the different aspects of the floating offshore substation. So it starts with the OSS itself. We are investigating HVDC of several power rates. We are investigating the different technologies, and we want to put in place prototyping, test, and be able to follow the design of these new assets. We have dedicated stream for O&M, failure mode, reliability, O&M strategy, dedicated stream on the cable, export dynamic cable, so for that particular case, DC cables. We have also streams in environment, impact on the environment, but also the climate change impact on the design of such assets. And last but not least, we have also the industrial aspects that are under our work streams, in order to study the different the supply chain able to support such big projects, the infrastructure, the execution plan to put in place, and the skills that we have in Europe and in France. AFOSS-DC answered a lot of the question that we have at RTE. It really paved the way of on different aspects that we have. All these aspects are here highlighted in orange. The main gaps that remains is on working with our supply chain directly with the manufacturer, I would say, of equipment, and to adapt to the site and to the condition, the French condition, the work that has been done. So as a summary, as I said, AFOSS-DC delivered the substantial outcomes on the substation functional specification, on the concept selection, which is a very important aspect with the water depth that we have in France. It delivered also a preliminary design of the OSS, but also of the dynamic cable. We had also outcomes related O&M, failure mode analysis, reliability analysis, And we also address the regulatory and normative aspects. What still remains to do, so it's to build on that and then to develop the technological blocks needed to realize the HVDC floater offshore substations, capitalizing on what has been done. Mainly focusing on the equipments and working with our supply chain, validating the design of these equipments with dedicated qualification campaigns involving, once again, our supply chain, putting in place some adequate experimental protocols in order to de-risk the technology confronted to the floating aspects and to the floating substation. As I said several times, we want to engage and involve our supply chain in this journey. We want to be able also to propose industrial solutions to the sector. And we want also to favorize the emergence and the consolidation of the European ecosystem in terms of supply chain and industrial players. And that was my last words about my presentation.